Bright Duty. Every student matters.
Now let us solve this numerical. If 1 mole of carbon atoms weigh 12 grams, what is the mass of 1 atom of carbon? Now we need to find out what is the mass of 1 atom of carbon. That means the number of carbon atoms. The relation should be between the number of carbon atoms and the mass. And the mass is already given to be 12 grams. Now let us see what is given. The given mass is equal to 12 gram. Alright, the given mass is equal to 12 gram. We know that the number N naught, N is equal to N by N naught. Alright, this is what is known to us, which is also equal to M by M. That is 6.022 into 10 to the power 23 atoms of carbon will be equal to 12 gram of carbon. Alright. Therefore, 1 atom of carbon is equal to 12 by 6.022 into 10 to the power 23. Alright. So, when we calculate this, we find that the mass of 1 atom of carbon is going to be 6 divided by 12 divided by 6.022 into 10 to the power 23 gram of carbon, which is equal to 1.99 into 10 to the power minus 23 gram. Alright, so this gives you an answer for this question.
Now the next question is, which has more number of atoms, 100 gram of sodium or 100 grams of iron? And here what is the given thing? That the atomic mass of sodium is 23 unit, whereas iron is 56. Alright, now we know that the atomic mass of sodium is equal to 23 unit, that is 23 gram of sodium contains how many numbers of atoms? So 23 gram, that is the gram atomic mass, which is also equal to the gram atomic mass. Fine. So 23 gram of sodium contains 6.022 into 10 to the power 23 atoms of sodium. Now here what they have given, that 100 grams of sodium will contain how much? So therefore 100 gram of sodium will contain 6.022 into 10 to the power 23 divided by 23 into 100, which is equal to 2.6182 into 10 to the power 24 atoms of sodium. Similarly, for iron, atomic mass of iron is equal to the gram atomic mass, which is equal to 56 gram. Thus, 56 gram of iron contains 6.022, that is Avogadro's number of atoms of iron, Therefore, again how much is it given? 100 grams. 100 grams of iron. So 100 grams of iron will contain 6.022 into 10 to the power 23 divided by 56 into 100, which will be equal to 1.0753 into 10 to the power 24 atoms. So if you make a comparison between the atoms of sodium and the number of atoms of iron, then we find that the number of, so which will be more, sodium or iron? So definitely the number of sodium atom will be more in comparison to iron atoms. Fine. So the number of sodium atoms will be more in comparison to iron atoms. I hope this is clear.
Now, we have to calculate the molar mass of the following substances. That means we will be now calculating the molar masses and different units, taking mole concept into account. The first one is ethyne. Ethyne, what is the chemical formula? C2H2, and they have asked us to find out the molar mass. Now the atomic mass of carbon is 12 and hydrogen is 1. Okay, and we need to find out what is the molar mass. So how do we find out the molar mass? The molar mass of C2H2 is equal to 12 atomic mass into number of atoms plus the atomic mass into the number of atoms, which is equal to 24 plus 2, which is equal to 26 gram. Because it is molar mass, so we are expressing it in grams. Next, sulfur molecule. Sulfur has a chemical formula of S8 and the atomic mass of sulfur is 32. So the molar mass of sulfur 8 is going to be 32 into 8, that is 256 gram. Alright. Similarly, for phosphorus, what would you do? You will take P4, this is the chemical formula. So the molar mass, the atomic mass of phosphorus is already given to be 31. So it is going to be 31 into 4, which is 124 gram. For hydrochloric acid, HCl, hydrogen has atomic mass of 1 and chlorine 35.5. Therefore, hydrochloric acid will have 1 plus 35.5, which is equal to 36.5 gram. So these are the molar masses of these substances. Nitric acid. Now what is the formula of nitric acid? HNO3. So hydrogen, as we know, hydrogen is equal to 1, nitrogen is equal to 14, whereas oxygen is equal to 16. So hydrogen is 1 plus nitrogen is 4 plus oxygen is equal to 16 into 3. Why 3? Because there are 3 atoms of oxygen in nitric acid. So it is going to be 1 plus 14 plus 3 6 are 18, 1 48. So we are going to add it. 8 4 12 plus 1 13, 1 4 5 6. So it is going to be 63 gram. Next, what is the mass of 1 mole of nitrogen atoms? What do you think? We know that the atomic mass of nitrogen is equal to 14. Alright, so this is the atomic mass of nitrogen. So 1 mole of nitrogen will be equal to 14 gram. Clear? Whereas if I have to do number B, 4 moles of aluminium atoms. Okay, the atomic mass of aluminium is given to be 27. And we need to find out what is the mass of 4 moles of aluminium. So here we need to identify what are the things, moles, and we need to find out the mass, and the molar mass is already given to you. So in this case, N is given to be 4, M is given to be 27. So we need to find out what is M. We know N is equal to M by capital M, or M is equal to N into M. So N is already known to be 4 and M is 27. (108 gram). So 4 moles of aluminium atoms will be equal to 108 grams. Alright. The next question is 10 moles of sodium sulfite. 10 moles of sodium sulfite. So we have to find out what will be the mass of 10 moles of sodium sulfite. Alright, the atomic masses are given: sodium to be 23, sulfur 32 and oxygen 16. Alright, now what is the thing that we need to calculate? We have to find out the mass of atom. Now let's do it. So what are the given things? The given things are N is equal to 10 moles. Alright, M we have to find out, which can be done with the help of this atomic masses. So for finding out M, what we can do, molar mass M of sodium sulfite is equal to 23 into 2 plus 32 plus 16 into 3. So we have 46 plus 32 plus 48. Alright, which is equal to 126 gram. Alright, so the molar mass of sodium sulfate is 126. Let us calculate once again: 23, 46, 32, 48, 8, 10, 16, 6, 5, 6, 7, 8, 9, 10, 11, 12. So 126 gram. So we know N is equal to M by M. Therefore, M is equal to N into M. So N is already given to be 10 and M is 126. Thus, it is equal to 1260 gram. So 10 moles of sodium sulfate will be equal to 1260 gram. Alright. Now let's go to the next question. Let us convert it into mole. Now how do we make the conversion into the mole? We know that 12 for number A, 12 gram, what is the given mass? Given mass of oxygen atom is equal to 16 gram. So for oxygen molecule, oxygen gas, it's going to be O2, which is equal to 16 into 2, that is 32 gram. Alright, now here they want to ask you that what is the number of moles for 12 gram of oxygen. For 12 gram of oxygen, it will be the mole of oxygen gas will be equal to 12 divided by 32. 12 divided by 32, which is equal to going to be 0.375 mole. Alright. Next, number B, 20 gram of water. So, what is the given mass? Given mass is going to be H2O, that is 2, or rather if I just put 1 into 2 plus 16, which is equal to 18 gram. So, mole of water is, what is it going to be? Mole of water is going to be 20 divided by 18, which is equal to 1.12 mole. Clear? Next, number C, 22 gram of carbon dioxide. So, the given mass of carbon dioxide would be, we need to find out the mass. Carbon dioxide would be CO2, that is 12 plus 16 into 2, 12 plus 32, which is equal to 44 gram. Therefore, mole of carbon dioxide is equal to 44 divided by, not 44 divided by this, 22. What is it given? 22 divided by 44. That is 1 by 2, which is equal to 0.5 mole. Fine. So, you already got the answer. For 12 gram of oxygen gas is equal to 0.075 mole. 20 gram of water is equal to 1.12 mole, whereas 22 gram of carbon dioxide is equal to 0.5 mole. What is the mass of 0.2 mole of oxygen atoms? The mole is given to you. You have to find out the given mass. Now again, because it is oxygen atom, so O is equal to 16. So the first one, N is given to be 0.2 mole. M, the molar mass of oxygen atom, is 16. It's already known to you. So you have to find out what is M. For that we know that N is equal to M by M, or M is equal to N into M. So what is N? 0.2 into 16, which is equal to 3.2 gram. So 0.2 mole of oxygen, okay, 0.2 mole of oxygen atom is equal to 3.2 gram. Fine. For the next one, N is given to be 0.5. Okay. M of water molecule is equal to 18. How is it 18? Because hydrogen is 1, so we have 2 atoms. So 1 into 2, 2 plus 16, which is equal to 18 gram. And M is what we need to find out. So M is going to be N into M. 0.5 into 18. 9 gram. So 0.5 mole of water molecules will be equal to 9 gram. Okay, so here you had seen in all these numericals we have been using the concept of mole. That is, we had made use of the relation of mole, 1 mole of any substance is equal to the number of particles that are present, that is the Avogadro's number, which is a constant, and it is equal to the molecular mass or the molar mass of the substance. And every time in each of these numericals, we are applying it again and again, depending upon our requirement. Calculate the number of molecules of sulfur present in 16 gram of solid sulfur. Now in this case, we need to understand what is the atomic mass of sulfur. Atomic mass of sulfur is equal to 32. Alright. So the molar mass would be equal to, as it is given, that the molar mass, it is S8. S8. That means there are 8 atoms. That is 32 into 8. So 8 2s are 16, 1, 8 3s are 24, 25, 256 unit. That means the molar mass is 256 unit. So this is the molar mass. Now here they are asking you to find out the number of molecules of sulfur. Now how would you do for finding out the molar mass? We already know the molar mass of sulfur 8 is equal to 256, which will be equal to 6.023 into 10 to the power 23 molecules. Clear? This is that. Now the question says that you need to find out the number of molecules for 16 gram of solid sulfur. So if 256 gram of sulfur contains 6.023 into 10 to the power 23 molecules. Therefore, 16 gram of sulfur would contain, what would it contain? It is going to contain 6.023 into 10 to the power 23 into 16 divided by 256. Clear? Which is equal to 96.35 into 10 to the power 23 divided by 256. Clear? So when you calculate, it is going to be 0.376 into 10 to the power 23, or which is equal to 3.76 into 10 to the power 22 molecules. Alright, so the number of molecules that is present in 16 gram of solid sulfur is 3.76 into 10 to the power 22 molecules. Alright, now let us do the next question. Calculate the number of aluminium ions present in 0.051 gram of aluminium oxide. Now there is a hint which is provided for this numerical. The mass of an ion is the same as that of an atom of the same element, and the atomic mass of that element is given to be 27 unit. That means the mass of an ion and the mass of the atom is same. Okay. Now with this information, let us carry forward. The very first thing what we need to do is we need to find out the molecular mass or the molar mass. So the molar mass of aluminium oxide, that is AlO3, is equal to 27 into 2 plus 16 into 3, which is equal to 54 plus 48, which is equal to 102 gram. So it means that the molar mass of aluminum oxide is 102 grams. Also, 1 mole of aluminum oxide contains 2 atoms of aluminium, which is equal to 2 into 27, that is 54 gram. So this implies that 102 gram of aluminium oxide contains 54 gram of aluminium. Alright. So what is given? It is given 0.051 gram of aluminum oxide. So 0.051 gram of aluminum oxide will contain 54 by 102 into 0.051, which is equal to 0.027 gram of aluminum. Alright, so this is the ultimate what we are getting. We also know that 27 gram of aluminum is equal to the Avogadro's number. And what is the Avogadro's number? 6.022 into 10 to the power 23. Or 1 gram, if I write it in unitary method, 1 gram of aluminum will be equal to 6.022 into 10 to the power 23 divided by 27. So therefore, 0.027 gram of aluminum ion will be equal to, what was the value? 6.022 into 10 to the power 23, alright, divided by 27 into 0.027. Clear? So 6.022 into 10 to the power 23 into 27, and what do? We remove the 3 decimal points. So 27 into 1000, which is equal to 6.022 into 10 to the power 23 into 27 into 10 to the power minus 3. Okay, divided by 27. So this 27 gets cancelled. So 6.022 into 10 to the power 20. This will be the number of particles. Alright. So the number of aluminum ions that is present in 0.051 gram will be equal to 6.022 into 10 to the power 20 ions. Alright, I hope this is clear to you. Alright, so again let me explain that the molar mass of alumina is calculated to be 102 grams. So 1 mole of aluminum oxide contains 2 atoms of aluminum, which is equal to 54 grams, and we know that 2 atoms means also the ions, because both have the same atomic mass. So 102 grams of aluminum oxide will contain 54 grams of aluminum ions, that is 0.051 gram of aluminum oxide will contain 0.027 grams of aluminum ion. And we already know that 27 gram is the molar mass. So the molar mass of aluminum, the atomic mass of aluminum is equal to the Avogadro's constant. Therefore, this many gram will contain how many? And this is, which is equal to 6.022 into 10 to the power 20 ions. So your 0.051 gram of aluminum oxide will contain 6.022 into 10 to the power 20 ions of aluminum. I hope this is clear. So this has been all the numericals that can be solved in relation to the topic that we had done already. Okay, now let us try and recap of what we had learned so far. This is of utmost importance that we revise it so that we can apply it properly in our coming sessions as well. Now, at the very beginning, we started with the concept of atoms, that is the smallest particle of any matter. There have been many schools of thoughts, and in all of these schools of thought, the scientists and the philosophers tried to justify that every matter is made up of very tiny particles, and they coined the term atom. On experimentation, it was formulated the laws of chemical combination. There are 2 laws of chemical combination, the law of conservation of mass, which states that mass can neither be created nor destroyed in a chemical reaction. Whereas the second law states that in a chemical substance, the elements are always present in definite proportion by mass. That means the proportion by mass that is present in a molecule of a compound always remains constant. Now, taking all these into consideration, John Dalton postulated the atomic theory. He gave 6 postulates. They are: all matter is made up of very tiny particles called atoms. He also accepted the fact that every matter is made up of very tiny particles. Atoms are indivisible particles which cannot be created or destroyed in a chemical reaction. Atoms of a given element are identical in mass and chemical properties. So an element will have same kind of atoms which are physically and chemically alike. However, atoms of different elements have different masses and different chemical properties. That is very obvious. Different elements will have different atoms which are absolutely different from one another. Atoms combine in ratio of small whole numbers to form compounds. So they are not fractionated. This is in accordance that atoms are not divisible. So John Dalton said that whenever there is a compound formation, the atoms of the elements are always combining in whole numbers. The last one, the relative number and kind of atoms are constant in a given compound. Why? It is in accordance to the law of definite proportion. So taking this into account, we had solved some problems. Now the question is, what are atoms? Atoms are very minute particles and their radius is measured in terms of nanometers. There are various minute particles that are present in every matter. That is, every matter is made up of these tiny atoms. Now, because we have different kinds of atoms for different elements, each of them have been symbolized through IUPAC nomenclature, where worldwide some symbols has been accepted. And what are the rules of writing these symbols? That we take the first letter of the name of the element in capitals, and in case we have the elements with the same initial, then we also write the second letter of the word, but that in the small. Alright. After the symbols comes the atomic masses. So much about the radius, the parameters. We also need to know the atomic masses. What is the mass of an atom? It is expressed in atomic mass unit, and one atomic mass unit is a mass unit equal to exactly 1/12 the mass of one atom of carbon-12 isotope. So they took carbon-12 isotope as the standard unit, and in comparison to that, the atomic mass units were formulated, which are constant for every atoms of every element. Next, what is a molecule? Molecule can be defined as the smallest particle of an element or a compound that is capable of independent existence, and it shows all the properties of the substance. We can have two types of molecules. It can be a molecule of an element in which the atoms are absolutely alike, whereas a molecule of a compound will have two or more atoms of different elements. If the atoms are of the same element, then it is a molecule of an element. If these are atoms of different elements, then these are molecule of a compound. On the basis of that, we had solved some numericals. What is an ion? Ions are electrically charged atoms. If they are positively charged, we call them cations, which is a characteristic of metals. And if they are negatively charged, we call them as anions. And non-metals are negatively charged. We also have another group of ions. We call them polyatomic ions. Polyatomic ions are basically clusters of atoms that behaves as single ion. This cluster of atoms carry some charge and they behave as single ion, and we thus term them as polyatomic ions. Okay. Next, what are molecular masses and mole concept? In molecular masses, for calculating the molecular masses, we take the individual atomic masses of the substances. So the atomic masses of the atoms of different elements are taken into account, they are summed up and the molecular mass is calculated. The further information is translated in the mole concept. In the mole concept, what we do, the species of particles that are present, that is either it is in the form of atoms, molecules, ions, particles, will always be equal to the molar mass of the substance. So taking this into account, we had formulated certain numericals. So on the basis, we had solved some numericals. We also saw how chemical formulas are written. While writing a chemical formula, what do? We write the symbols, then we write down the valencies or the charges carried by these elements, and then we crisscross them and write down the chemical formula. And once we know the chemical formula, we can find out the molecular mass of that compound by writing down the atomic mass of each of the individual atoms of the element that is present. Alright, so I suppose all this will give you a clear picture of what atoms and molecules are and how do we include this concept in solving numericals through the mole concept. So if you have any doubt, do let us know and get your doubts cleared. Till then, take care and goodbye.